And my screen just changed. Holy cow, that is on my email.
Well,
You can't look at that. But anyway, here we go. We're going over inequalities today. We're going to start with basic inequalities, then solving them, compound, and then some in-depth questions to see if you really get it at the end. So, right here, how would you read that? Well, we like to always start with the variable because that's what we're going to be dealing with. X is greater than or less than something. So sometimes they're this way, sometimes they're flipped. Always start with your variable. So if I put X here in a number, we'll say X. Well, see how this end's open? It's bigger. It's like it's eating the X. So X is greater than 2. That's how I'd read it. So now we're going to draw it on a number line if I didn't just get rid of everything. So how would I write X is greater than or equal to 10? Well, one thing you've got to remember, if they're equal to, when you make your circle on a number line, you're going to close it up. You're going to color it in.
Included.
Included. And open if it's not. So there's your little note. So go kind of hand in hand when we graph inequalities because you'll make dotted lines and all.
Make sure you have this written down somewhere. You want to remember whether it's open circle or closed circle.
All right. So right now, closed circle, 10 is going to be included as an answer. So I give you a blank number line because I want you to draw your own. Well, 10 is my focus number, so I'm just going to put 10 right here in the middle. It's closed, so I know I'm going to have a colored-in dot represented. So now, X is greater than or equal to 10. So greater than is going to be to the right, so 11, 12, put a 9. I'm going to shade it. And put an arrow because it goes on forever. Every number greater than or equal to 10 works as a solution. So I can plug anything in. Next one here, do it backwards. Okay, if you can't read it going from right to left, you can spin the whole thing around. This is one method I show students. I can grab it, turn it around, and say, oh, C is greater than 11. But that just kind of looks weird now. So C greater than 11. So 11 is the focal number here, focus one. So 11, 12, 10. It's not underlined, so it's an open
circle.
X or C is greater than, so the right on the number line, so every number greater than. And now you've graphed and shaded the inequalities. Coach Ramsey, here's some more room. A little bit more, not too much. There you go.
Right, so we're moving on here. I like to go ahead and decide whether or not I'm going to have an open or closed circle. There is a line underneath. It might be kind of hard to see, but there is a line. So I know that my circle means it's going to be included. We're including the 9. So X is greater than or equal to 9. So we'll go ahead and write our 9 here. We know that this way is the greater numbers. To the left is smaller numbers. Right? So we already decided we've got a closed circle. X is greater, so we're going to the right. Right? The bottom one here, again, I like to start with my variable. So I'm going to start with my V. V is less than 10. Right? We're not including 10, so we know that means that we have a open circle. Make some room here. We've got an open circle. We'll draw our 10, 11, 9. Right? So open circle. V is less than 10. Less numbers or smaller numbers are to the left. Right? So we graph another inequality.
Whoa. Alright, so we're going to solve these the same way as we do the equations, except you're going to write this down. This is an example and a non-example, so you can see the difference. When you divide or multiply by a negative, you will flip the inequality symbol.
Let's say that again. When you divide or multiply by a negative, you flip the inequality symbol. You flip the arrow. Right?
Alright, so let's work it out and see here. Alright, so pretend the inequality symbol is an equal sign. I'm going to move the constant over. Get a 4. Keep that symbol the same. So now, the next step in solving this is to divide by a negative.
Dividing by a negative.
So, since I divide by a negative 2, I need to remember to turn that symbol. So, bam, turn it that way. So, x is less than negative 2. That's what the rule is. That's what you got to remember. Alright, Ramsey over here, give us a different one.
Alright, over here, we've got 3x plus 12 is greater than 9. 3x plus 12 is greater than 9. We're going to solve it just like we would in an equation. So I'm going to subtract my 12, both sides. Right? Now I've got 3x is greater than a negative 3. Right? To get the x by itself, we'll divide by a 3. So, negative 3 divided by 3. Well, we know we're going to have an x. We know this is going to become negative 1. So now I'll ask you, do we flip the sign? Did we divide by a negative? No, we didn't. We didn't divide by a negative. Yes, we get a negative answer, but we divided by a positive 3. So we don't flip that arrow. X is greater than negative 1. So all numbers greater than negative 1 would make this inequality statement true.
Yeah. Try them.
Click pause. Give it a try.
I'm going to wait on you. I'm tired of it.
Man, that was fast.
Yeah.
All right, let's work them out.
Let's say 3x greater than 33. Divided by 3. Add positive. All right, we ain't changing nothing. So there's your answer. X greater than 11.
X is greater than 11.
All right, let's divide by that number. Now, here's something I see. If you're still having trouble reading this, it's negative 3 times x. I have a lot of students like to add 3 here still for some reason. Negative 3 times x.
If that number is right beside a letter, that means multiplication.
Did I divide by a negative? I don't know why I looked at you. You can't tell me. You're in a computer. God. Flip it. Yeah, flip it. Negative 8. Gotcha.
X is greater than negative 8.
And last one. Hopefully you're done. Oh, I hit the wrong button here. Alright, minus 4. Minus 4. 26. Greater than negative x. Not done. That has to be a positive there. So we're going to divide by a negative 1. So I can
write it up here so you can see it there.
Yeah, he got this.
26.
I'm rocking out.
There you go. Are we done? Can we leave it as negative x? No, because, hopefully you guys know, there's technically a 1 right there. You don't have to write it, but technically there's a negative 1. So we have to divide by a negative 1. Well, 26 divided by negative 1, all that does is change it from a positive 26 to a negative 26. But remember, we divided by a negative, so we have to flip the arrow. Right? So we're going to read that as x is greater than negative 26. Yes, you could also write it like this if you want to, if that makes you feel more comfortable. It doesn't matter. X is greater than negative 26.
I just want to fly. All right. This is the level that we want you to be at.
We won't make you click pause there.
You shouldn't try it, but you won't get it right. You may, I don't know. Alright, so variables on both sides. Do I have distributive property? No. Do I have like terms that combine? No. But we do have this entire numerator being divided by 4, so I'm going to cancel out the 4. Well, not cancel out, but relocate it and get rid of it, whatever you want to call it. I times it by 4. So I times that side by 4, and we get 2x plus 1. Since it's a positive 4, it's not going to change anything. And I need to multiply both terms over here by 4. So it's going to become 40x.
These are the same skills you guys have been doing when we've just been solving equations. We're doing the same skills, now we're solving inequalities.
Okay, variables on both sides. I'm going to quickly solve it now. Not really any difference in anything we've been doing. 17. And we should get a fraction or decimal answer here. X is greater than or equal to 17. 1738.
If you got the decimal answer, you know you're looking at 2 point something. We won't make you get that definite.
Not today, at least. All right.
Maybe about 2.3.
Here's you another example. Get it.
Ooh. Click pause. All right, let's see if you guys got it right. So, similar to the one we just did, it's kind of been flip-flop, but we're still going to multiply by a 3 to both sides. Right? So, I'm going to go ahead and mark these 3's out, and we're going to distribute over here on the right. So, 3 times 3x is 9x. 3 times negative 8, don't forget that negative sign. 3 times negative 8 is negative 24. And I'm just going to simply bring down my numerator on this side. 8x plus 6. So now I've got 8x plus 6 is less than 9x minus 24. So we got variables on opposite sides of the inequality sign. So I'm going to get those on the same side. I'm going to subtract the 8x so that I can keep my variable positive, right? So I'm subtracting 8x, so it goes away over here. And I'm left with 6 is less than 1x, or just x, minus 24. Now we've just got a one-step equation here. I'm going to add my 24 back to the other side. So now I've got 30 over here, and my x is on the right. I'm going to read that as x is greater than 30. X is greater than 30. Right?
Sweet, you nailed that.
Ooh.
Let's get it. Last example, and we'll just fly through this. Times 4. And the reason this works timesing by 4 is that's 4 over 1. That becomes a negative 8x plus 4 over 4. And each one of those can be divided by 4, and it becomes the numerator itself. So that's kind of why we're just saying multiply by a denominator and it's gone. So we got negative 2x plus 1 is greater than negative 32x plus 20. Add that, we get 30x. Subtract 1, we get 19. X is going to be greater than 1930s. Yes.
You get the fraction ones.
Yeah. I can handle that. All right.
Compounds. Inequality.
So these have to meet certain things. Like this one is an OR statement. So there's technically 2 sections on a number line that could have the answer. This or from there. So we'll model these with a number line, a few of them. So I'll start this first one. Since it's separated by OR, this is what we're going to solve. Then we're going to solve that. We can do it at the same time. Ramsey will get that side, I'll get this. These are one step, so we
One
should
step. Only you guys can do 2 at the same time.
So our answer could be x is greater than or equal to 3, or any number less than 2. So using a number line, we have a 3 and a 2. And then at the 3, it's going to be colored in.
Yep.
And it's everything greater. And at 2, it's open. It's everything coming up to the 2 and below it. So that's what our answer would be modeled by. So just this little gap doesn't work in whatever we're talking about. Okay. Now the and ones you solve them the same way, but at the end we're going to have to put them together differently. Again, we'll each solve the sides, speed it up for you.
So I'm going to add 6 over here.
I'm going to subtract 5.
Oh, okay.
What are you going to do about that?
Boom. X is less than 18.
I got the big one. This ain't fair. X is greater than 2.5.
Okay. He's good with fractions, so he knew that 5 over 2, same thing as 2.5.
So since it says and, we're not going to write and in between. We're going to use these symbols and write it like a compound inequality, something like that, with our variable in the middle. My method is I look at my symbols. I like, since they're the same, equal signs and stuff, I like everything pointing left, because that tells me my smaller number goes here, my larger number goes here. So x is got to be greater than which one of these? 2.5. But x also has to be less than 18. That's how I'd write my answer. If I was going to model it on a number line, we'd have two numbers of interest. So we'd have 2.5 here.
What would our circles look like? Would they be open? Would they be closed? One open, one closed? What do you think?
So it's bigger than this, but less than that. So it's everything in between those.
Two open circles.
So with and or anything that starts off like this, that's how we're going to write our answers back like with two symbols. All right, here we go.
Ooh.
Here's our other one, the third variety.
So we've got another compound inequality here, right? Now, this one, a little bit different than the ones we just did. They are combined together, right, already. So how can we solve these? Well, the good thing is we've already solved some, regular 1- and 2-step inequalities. So we're going to solve it basically the same way, but let's do this example together. So if I just had what's over here on the left, I think you guys can handle it. If I just had what was over there on the right, I think we could do it. So we're going to solve it the same way, but whenever I add 2, I got to add 2 everywhere, 3 different places, right? So when I add 2 here, I've got 12. It goes away there in the middle. These 2's kind of cancel out. Keeping my signs the same. 31 plus 2 is 33, right? So now we've got one more step to do. We're going to divide by 3 in this case. Divide by 3, 3 different places, right? So 12 divided by 3 is 4. 33 divided by 3 is 11. So x is going to be less than 11 and greater than or equal to 4. Right? X is greater than or equal to 4 and less than 11. So on a number line, hopefully you guys have this copied down already. We can make our number line. We got 4 and 11. I'm going to go by 2s. 2, 4, 6, 8, 10, 12, right? Obviously, you got the smaller dashes here. So, our first circle here at 4, open or closed circle, that's going to be closed because we're including the 4. At 11, we're going to have an open circle. It's going to be less than 11. Right? So when x is less than 11, greater than 4, our dots or our circles will connect again. We got one closed circle, one open circle.
Right. So I do something a little different with this type with mine because I'm going to create a little different equation. It may not work, it may work. I'm going to throw in another x plus 4 here, and this may not be sufficient. Okay, it may not make sense as our answer, but I'm just going to show you how I had my student tried it. So I do a little different. I don't care if you like his way better or mine. As long as you get the right answer, it don't matter.
We just want y'all to get it correct.
So I view the center as being included on both. So I cover up one symbol and what's to the right of it and rewrite it in this form. So 2x plus 4, well, that did not work up. Symbol 3x minus 2. So I take what's here in the middle and I use it with everything to the left to create up one equation. Then I take what's in the middle again, minus 2, x minus 10. Set up another equation. So these are my two parts. I like to pull it apart first because I might get confused with all those numbers and I see it with my students a lot. So that's a plus sign. So now I can solve it, add 2, divide minus 2, go through it. So that's my strategy. So if seeing all that coming straight down was overwhelming, this is my way. I can solve this, get that answer, then put it back together. It's whatever you prefer. So try this one on your own. The Unicode range will each do a side. Go ahead, pause it, try it. Welcome back.
Hey.
That was a big break. So we'll solve this.
All right. We'll multiply by 2.
Oh, I divided by negative. I had to flip this thing. That's complicated. Oh, it says and, so we got to put it together. Dang it. Oh.
I got x is less than 10.
So x, I got greater than or equal to -5. So it's got to be between -5 and 10. Next one says or. Oh, these are easy. So he just solves his, I solved mine, we're done.
B greater than or.
And that's our answer. That or that. And again, work ahead of us. Oh, no, you ain't going to now. I challenge you. Can you answer this? Which is greater? Given x plus 5 or 3x plus 2 if x is 8?
Y'all can do that.
I hope so. Don't worry about that. If you don't know, I'm telling you here, if x is 8. So where x is, we're literally going to put 8. So that's 3 times 8. 24 plus 2 is 26. That's 8 plus 5, which is 13. So the greater one was 3x plus 2. All right, that's a confidence booster.
I can do that.
All right, here we go.
Statement, y is less than x. Which is greater, x minus y or y minus x? Now, I understand you might be thinking, wait, where's the numbers at? There's only letters. I don't know what to do. I get it. It can be confusing. So, what I like to do, let's plug in 2 numbers to make this statement be true. It doesn't matter which numbers you pick. Y is less than x. So I'm going to keep it simple. I'm going to make y a 1. I'm going to make x a 2. You guys agree? Is 2 greater than 1? Yeah, it is. So let's keep these 2 numbers. Again, I made x a 2 and y at 1. Well, 2 minus 1 is 1. Or, same thing, we said y is 1 minus a 2. Well, 1 minus 2 is negative 1. So which is greater, x minus y or y minus x? Well, in this case, x minus y. X minus y is greater. That's going to be true every time, no matter what numbers you choose, as long as you follow this statement. You could have said y is 50 and x is 100. It would work the same way, right? As long as you follow this statement.
Woo! Yeah, I get these 3 stipulations. This is stupid. I don't like it. It's all letters. It's like my shirt. Like I cannot read that. I'm physically educated, not mentally. It's done. All right, so x is bigger than 0. Okay, it's a positive number. Check. Y is bigger than 0. It's a positive number. Okay, so we got positives.
And
That x divided by the y is always going to be greater than 2. So that means when I divide those positive numbers, x is going to be a lot bigger. So if I divide the opposite, it's going to be 2 times the size of the other one. So I can pick a number like 9 and divide it by something, it's got to be greater than 2. So divide by 3 maybe? Is 9 divided by 3 going to be greater than 2? Yeah. So let's try 9 and 3, see if that works. So 9, is that greater than 2 times 3? No? So any way we put it, x is always going to be greater than 2 times y, because the outcome of dividing them, it's always going to be bigger than 2 anyway. We could get really close, but it's never going to actually be equal to 2. So doubling this, it's never going to be greater than that. I probably confused you, but all right. Next one. All right. I'll take the top.
alrighty.
Statement n is an integer. All right, we got a number here. Just a number. All right. Which is greater? N or negative N?
Come on now.
Aren't integers positive and negative numbers? Or are they positive numbers only? I'll let you Google that one yourself. This is a you decided. I ain't telling you the answers. You can't copy me no more. Once you know what an integer is, you can find that answer. Go ahead, Ramsey. Coach them through it.
All right. Statement. A is greater than 0. B is less than 0. Which is greater, A times B or A divided by B? Well, if A is greater than 0, we know, again, it's a positive number. If B is less than 0, we know it's a negative number. So just to kind of keep it simple, I'm going to say that my A for this one is going to be 4. My B, in this case, I'm going to use a negative 2. Negative 2 is less than 0, and 4 is greater than 0. So I'm listening to what the statement says. So 4 times negative 2, well, that's negative 8. And then 4 divided by negative 2, well, that's negative 2. Which is greater? Oh, 8's bigger, right? Slow down now. Negative 8 is less value than negative 2. So the greater would be our A divided by B. Always. As long as you follow this statement.
Or, do we not know? Let's see something here. Maybe I'm reading it wrong. I don't know. Let me change that to a negative 1. What happens then?
Ooh. 4 divided by negative 1 would be a negative 4. Negative 4 is still greater.
Oh, it's 4 times negative 1.
Negative 4. So is negative 4 greater than negative 4?
Well, which is greater than this situation?
It's not.
We don't know. So there's not enough information here to know. We can't know which is greater. We know probably that one will be greater most of the time, but clearly right here it's a tie. They're equal to each other. That's a very tricky one.
Tricky.
Yeah. And last one. 5 is greater than 4. Duh. So 5 times a number or 4 times a number, which is greater. We don't know what x is. If it's a 1, you're bigger. If it's a negative 1, that's bigger. We need more information.
More info.
So we can't decide that. Down here, 5 divided by 4, it's kind of the same thing. If we had more information, like let's say x is greater than 0. Now what's the answer going to be? We'll give you more information. X is greater than 0. So we're dividing these by some positive number. So the answer is always positive. Divide by 2, divide by 2. So that's bigger. So with that extra information, boom. If we flip the inequality symbol, does it change the answer? Now, is it still the same? So we're dividing by negative. Divide by negative 2. Negative 2.5, negative 2. Bigger. Still bigger. So sometimes you gotta use more than one number because it may be something we can't figure out. We need more information, which sometimes are choices on math tests. So this is our overview of inequalities. We've solved them, graphed them on a number line. Try to refresh your memory on how to read them. So yeah,
Good luck.
toe touch. Woo.